Hello, everyone. My name is Brandon Kramer, and along with Gizem Korkmaz at the University of Virginia and our colleagues Bayoan Santiago-Calderon at the Bureau of Economic Analysis and Carol Robbins at the National Center for Science and Engineering Statistics, we'll be presenting on international collaboration systems in open source software using longitudinal network analysis to examine GitHub activity. To start the presentation, I'll go over some brief background on both open source software as well as what network analysis has showed within the domain of international collaboration. Next, I'll go into the data collection and methods for this project, including how we developed a package to scrape targeted GitHub data, including user and commit activity. From there, we constructed networks. And while we examined both contributor and country level networks, the main focus of today's presentation will be examining longitudinal trends in the country-to-country collaboration networks. The results presented in this presentation are part of a broader collaborative agreement between the National Center for Science and Engineering Statistics and my colleagues and I at the University of Virginia's Biocomplexity Institute. Currently, the NCSCS and other economic indicators do not do well in measuring the scope and impact of open source software as they're developed outside of the business sector. It's for this reason that we're really interested in examining the scope and value of open source software. In fact, our past research has gone into much more deep detail about the stock and flow of who uses open source software, how these products are created, and the overall measure of value for OSS products. Now we're looking to shift gears and examine collaboration networks in the context of OSS. This includes better understanding the structure of OSS collaborations, as well as how they span across different geographic boundaries. So what is open source software? OSS is essentially any software that's published under an OSI-approved license. These licenses establish permissions and limitations for how one can use, inspect, modify, or distribute the software. One can essentially take the software from online and either expand or repurpose it for whatever one wants, as long as they follow these permissions and limitations. Prominent examples of OSS include the Apache web server, Linux, Mozilla web browsers, and the analytical tools like R and Python that many of us use to conduct network analysis. Now, past research has been done on network analysis in the context of OSS, but these are typically smaller scale networks and fail to capture the broad scope that we're looking at here when we're looking at our GitHub data. To date, there's been quite a bit of research on international collaboration, mainly in the context of academic research. From this literature, we know that international collaboration has more than doubled in academic papers since 1990. We also know that governmental funding, particularly from outside of the US, has helped expand these tendencies, and that ultimately leads to higher impact publications, though not necessarily more publications overall. With this in mind, we were interested in expanding our understanding of how international collaboration has manifested within the context of OSS. This includes asking questions like which countries are most likely to contribute to OSS, which countries are most likely to collaborate internationally, what's the structure of international collaboration and how does it change over time, as well as finding out what the most influential countries in the OSS ecosystem are. To do this, we use network analysis to study individual and country level collaboration. To collect data for this project, we developed an open source Julia package called ghost.jl. This allows for targeted scraping of activity and user data from GitHub. In the first stage of this process, we collected all of the public repositories with an OSI-approved license. From there, we were able to extract all the development activity, including commits, additions, and deletions from those repositories. In turn, we were able to collect all of the contributors that engage with these repositories. From there, we then merged this data with the GHTorrent data that's available online. This allowed us to supplement the existing data that we had with user login, email, location, and company information. We then developed an algorithm that was able to convert all of the location data to consistent country codes, which we were then able to combine and construct our network data. When we look at our original data set, we see that it's comprised of 3.3 million distinct contributors and 7.8 million distinct repositories. However, in order to construct an international collaboration network, we had to join this with the user data from the GHTorrent data set. This brought our totals down to 333,000 distinct contributors and 3.5 million distinct repositories dating from 2008 to 2019. As you can see below, the number of contributors from the US are significantly higher than all other countries. This is about 6 times higher and about the total of China, UK, Germany, and India combined. Now, to convert these commit and user activity into network format, we projected a bipartite login repository network into single mode contributor networks. If you think about this visually, on the left-hand side, we see that contributors are represented in blue, and they are contributing to a common repository in orange. When we project this repository out, we end up with the visual on the right-hand side where contributors that have committed to a common repository are connected together through those ties. This is the representation of what we analyzed in the contributor network. And in order to convert that to a country-to-country network, we essentially aggregated all nodes or users within a given country into one node or supernode. And those edges correspond to the number of international collaborations between those countries. We analyzed these longitudinally using R's iGraph and gggraph packages, as well as doing visualizations in Gephi's software. Moving on to our results, let's first look at the number of international collaborations that happen within each country. In this chart, you can see on the y-axis that we have the number of GitHub collaborations per country in millions. And along the x-axis, we have the top 15 countries based on the total number of collaborations from 2019. A number of things should pop out in this chart. First, the US tends to engage in significantly more collaborations than all other countries. In fact, they have more collaborations than Germany, the UK, France, and China combined. The second thing that pops out is the number of domestic collaborations in orange. You can see that the US has significantly higher tendency to collaborate domestically than all other countries. And this likely comes from the fact that the US is just dominant in terms of OSS development on the GitHub platform specifically. We also see that in light blue that countries tend to collaborate with US-based developers. And this, again, is likely an indication that OSS is dominant, but it's surprising that Germany, UK, and many other top countries tend to engage in collaborations with US-based developers at nearly 2 to 4 times the rate than they do developers in their own country. And we don't have a direct comparison for how these results would match up to the publication space. However, the NCSCS does have a proxy for comparing these two domains. In their analysis, they've looked at the number of articles that have international and domestic collaborations. And when we compare those proportions, which are roughly similar but not exactly the same, given that we're looking at the number of international collaborations here, we see that the United States has roughly the same number of proportion. However, most countries tend to have 30 to 60% higher rates of international collaboration within the OSS space. Overall, this tells us that users and developers on GitHub tend to engage in international collaboration significantly more than they would on publications. Next, let's take a look at the longitudinal trends in the country-to-country network. As you see in figures A, B, and C, the nodes, edges, and commits all grow at varying degrees within this country-to-country network. Overall, the nodes grow quite rapidly until about 2013 before they begin to plateau. In contrast, the edges and commits grow even more rapidly, with the commits reflecting the trends that we see in the contributor level network, which is all exponential across the nodes, edges, and commits. The nonlinear trends observed in plot D, or the communities, are quite interesting. What we initially see is an increase, a decrease, an increase again before a decrease after about 2017. This largely reflects the upper bound number of countries that can exist within the network. Essentially, they're able to join, and then they join as isolates and then begin to cluster together into smaller regional communities. And the same thing happens around 2017 to 2018. We would expect to observe a continued decline in the number of communities over time, given that we already met that upper threshold, and we would only expect communities to begin to cluster together more and more over time. We also conducted community detection analyses on the country-to-country network. You can see here, these are our initial results that did not include any self-loops, which are, in this case, domestic collaborations. The end result are 2 large communities in dark and light blue, as well as 2 smaller communities in orange and yellow. We didn't think that this wasn't very interesting or made a lot of sense, so we decided to introduce those domestic collaborations back into the network. You can see here the marked contrast between the original analysis on your left and those with the domestic collaboration on the right. In the first analysis, we had 4 communities. In the second analysis, we have 46 different communities, but about 20 of those are individual isolates. or individual countries that are communities of their own. So what you see here is those countries added together, and what we start to see are communities that are clustering essentially by region. We have different regional communities form in the Nordic countries, several African countries, South American countries, and the former Soviet Union countries all form an additional block, if you will. We also see in dark blue that there's another community that seems to span South Asia, Africa, South America, and Greenland and Iceland above. This is particularly interesting for the NCSES to kind of examine these different regional clusters and try to understand how OSS might actually be geographically or linguistically bound. We don't quite know what factors are driving this community clustering quite yet, but our hope is to continue developing these and run a regression analysis to try to be able to try to predict how these communities form in the country-to-country network. We also compared centrality measures between these countries. Essentially, we're trying to look at different kind of brokering dynamics based on the betweenness centrality versus the degree centrality. Here we see in this chart that we're comparing the degree on the x-axis and the betweenness centrality on the y-axis. Essentially, what you'll see is that the higher the node is on the y-axis, the higher the betweenness relative to degree centrality is, and we suggest that this is a higher proclivity towards or a higher capacity towards having a brokerage within this country-to-country network. Overall, we see that the US, Canada, China, Nigeria, and Kenya, as well as a number of the other countries that are labeled in this graph, tend to have higher relative betweenness centrality compared to their degree centrality. We also looked at the average betweenness centrality when broken down across the network. In light blue, this is the average for the overall network with all countries combined, where we see that the dark blue is the top 25% of nodes and top 10% of nodes are in orange. Overall, we would expect to see betweenness centrality continue to grow if those certain countries have more brokering capacity or influence in this case. But we actually see that the top countries in orange tend to have a lot more betweenness centrality or brokerage capacity relative to other countries up until 2013. And that essentially has plateaued since that time and is now even slightly declining since 2017. This just suggests that even though those top countries still have a huge amount of influence over brokering and development within the OSS community, that seems to be declining over time, and that will likely change as other countries join the network and begin to develop with more enthusiasm. Overall, we see that the GitHub contributor networks, which we didn't talk about a ton in here, we essentially see that US-based users are most likely to contribute to GitHub, and that's not surprising given that the platform initially developed here and is most widely used by US contributors. We also see that over the past decade, the number of nodes, edges, and commits have all grown exponentially. In a similar way to scientific collaboration networks. Now, in this presentation, we looked more closely at the country-to-country networks, and the main takeaways there are, first off, when we look at those centrality measures, we see that the US has a tremendous amount of influence in the OSS ecosystem, and that's indicated not only by the number of collaborations, but also the high number of commits that they have, both domestically as well as internationally. And we see, again, that countries tend to collaborate with the US quite a bit, in fact, even more often than their own domestic partners. And we also see that the country-to-country networks can tend to cluster into these 4 large communities, but when we looked more specifically, we saw 26 different communities form that were meaningful, and those tend to cluster based on regional influences, but likely a number of socio-political factors related to linguistics, law, and potentially even certain economic factors that might be driving the confluence of those communities. Overall, we think that social network analysis is really important to continue to develop and understand international collaborations, much like we see within the publications domain. And we're hoping that the continued use of social network analysis can lend to these analyses, not only that the National Center for Science and Engineering Statistics is conducting, but it could also feed into a number of other agencies and hopefully develop metrics or indices that we can use in the national accounts moving forward. And with that, I want to thank you for your attention and invite any questions on behalf of me and my colleagues. Thank you.